Okay, we are continuing on chapter 5, Decisions of Java Concept or Big Java book by K. Horseman. That's part 7 that we are covering is called Boolean variables and operators. So we talked earlier about the if statement and how the expressions that you have inside the if statement is going to be calculated to a Boolean. Means true or false, or in the computer language, it's going to be 0 or 1. So it's just one bit that's going to be used, and it only knows about true and false. Nothing else can be in there. It cannot put anything in there. So it only has 2 values. So we can assign a true or we can assign a false on it, and then we can check it. So one thing about the Boolean is you can put it right there. So by itself, I don't have to worry about it. So generally, whatever statements that you have inside your if statement has to be changed to this Boolean variable, which is true or false. So in this case, because I set it to true, it's going to be true in here, and if some condition changes, we can change it to false. So we call them a flag generally, that in a racing car, a flag can be up or down. So if something happened in the racing car and there is an accident or something, then the flag is going to change its position, meaning that don't go, stop. And if the flag is down, then that means they can go, or vice versa, however you want to think about it. So there is a flag that's up or is down. So if we ignore the yellow light, the red is going to tell us to stop, the green is going to tell us to go. So it's going to be only 2 conditions that we can use for our flag. Now we are going to be talking about some complex decisions. This is not only happen in computer science, we have this in the philosophy, logic, and you may have taken a course over there, you might have seen this over there. So this is something that happens more than just computer science. So we are talking about and or. And is going to be represented with the 2 ampersand sign, 2 of them, not 1. And it can be only true if both condition is true. So I'm going to tell you, you have to do problem 4 and 6. That means you have to do both. So you don't have an option to do. On the other side, we have or, which is straight line that is shift backslash. That is going to give you or. Or means you either one of them has to be true for the whole thing to be true. So if I tell you do problem 4 or 6, so if you do problem 4, you're good. If you do problem 6, you're good. If you do both of them, you're going to be still good. So that's the difference between the or and. So let's go over them a little bit. So the first condition is true. The second condition is true. The whole thing becomes true. Anything else that goes, any of them, if the first one is false or the second one is false or both of them are false, the total is going to be false. In the other one, for the or, if I have either one of them true or both of them true, the whole thing becomes true. And the only way that's going to be false if both of them are false. Then we have something else called the not. Not is just going to change the original. So not true is going to give me false. Not false is going to give me true. So this is something that we're going to be practicing moving forward. So we are doing the testing to see if the water is liquid at given temperature. So in this case, we are concerned about if water is liquid or not. Yes or no, that's it. So we're going to be looking at some temperature. So if it is greater than 0 and at the same time is less than 100. So we're covering temperature 1 to 99. So it is greater than 0 and at the same time less than 100. So if I have a negative number, the first one is going to be false, or even I have 0, the first one is going to be false. And remember, for the and, as soon as we see a false here, the whole thing becomes false. If the second one is false, that would be temperature is 100 or above 100, then the whole thing becomes false. So the number has to be 1 through 99 for this condition to be true. So for the flowchart on and, we're going to check the first one. If the first one is true, we're going to check the second one. And if the second one is true, we're going to go as a true. If any of them is false, we're going to get out. So there is something here that's called short circuit. And to be efficient Java compiler, it's going to check the first one. If the first one is false, it's not going to even check the next one. Doesn't need to check the next one. All right, so let's say that we want to use the O. We want to check to see if it's not liquid. So if it's not liquid, remember, if it's liquid, it's between 1 and 99, and we want to check it to see if it's not liquid. So we're checking to see if it's less than or equal 0. Remember, 0 was not covered on the other one. If it's greater or is greater than or equal 100, then it's not liquid. I have seen some people put an and over here. There is no way that you can find a number to be less than 0 and greater than 100 at the same time. So we got to be careful when we're building this stuff. So the flowchart for the or, we come down to the temperature less than equal 0. If it's false, we're going to check the temperature greater than 100. If both of them are false, we're going to get a false, we're going to get out. If this one is true, we're going to go out. If this one is true, we're going to get out. So for the short circuit, as soon as we see the first one is true, we don't have to check the next one. If it's false, we're going to check the next one. And if this next one is true, then the whole thing becomes true. All right, let's go over some of these things for practice purposes. We putting numbers here to make it clear, but generally you have variables for these, and we're checking our variable, and it's not as clear as this with the numbers. So let's go over this together. Take a few seconds to think about it. We have an expression. It says 0 greater than 200 and 200 less than 100. So the first one is true. But remember, for and, both of them have to be true. 200 is not less than 100. So the second one is false. And for that reason, the whole thing becomes false. All right, we're going to the next one. We have 0 less than 200. Is that true or false? 0 is less than 200. For the or, as soon as I see a true, the whole thing becomes true. I don't even need to check the next one. But I can check it. So 0 less than 200. So the second one is false. The first one is true. So the whole thing becomes true. Now let's move it around. What about if 0 is less than 200 or 100 less than 200? Again, as soon as I see that 0 less than 200 is true, I don't need to check the next one. But it is a true on the first one, is a true on the second one. For the OR, it becomes true. Okay, what about the next one? We make it a little more complex. So we are looking at x greater than 0 and x less than 100, or x equal -1. So we have a lot to cover here. So for the first part, and an OR are on the same level. So if we see more than one of them, it's going to be working from the left to right. So if my x is between 1 and 99, the first part is going to be true. It doesn't even check the next one. If one of them is false, then it's going to check to be sure it's -1. Okay, so next one, you can see the symbol over here. We do not have this in Java. We cannot do this. So we have to break it down. So this is not acceptable in Java. Your compiler is going to complain about it. So what is this set? It says x greater than 0 and x less than 100. We have seen this before, just right here. So we cannot do this. Now, what's the problem with the next one? Why is it telling us this is an error over here? So we are thinking that x and y are going to be less than 0, but this is not what it does. Because the and or have lower precedence, the greater than is going to happen first. So we are looking at y greater than 0. That's going to be return false or true. And then we have x and false or true, and that is the problem. We cannot do that. Java doesn't let us do it. Okay, next one is talking about not. So this is a symbol for not. That's shift 1. So we are checking to see if this is true or false. So 0 less than 200 is true. So the not is going to take the true and it's going to change it to false. If it was false, it would change it to true. So it's just going to make it opposite of it. Okay, so it's checking to see if frozen equal true. So it's checking to see if it's frozen. So we're checking frozen equal true. That's a Boolean one. So we technically don't need to check it this way. So we could simply write down if frozen. So we don't have to say if frozen equal true. The if frozen is going to check it to see if it's true or false. Same thing goes with the next one, that if you want to check it for the false, all I have to do is just put a not in front of it. So this is checking it for the false. So not is going to invert it. So not equal is going to basically not is going to change it true to false. and it's going to change the false to true. Reminds a non-frozen ice cream. So you can see how we're going to check it. We're going to say if not frozen, then we're going to do something about it. Okay, let's go over the self-check. So suppose X and Y are two integers. How do you test whether both of them are zero? We want to be sure that both of them are zero. How do you do that? How do you test whether at least one of them is zero? So we have two integers. I want to say at least one of them is zero. So if two of them are not zero, I'm okay with it. Just one of them is going to be zero. How do you test whether exactly one of them is zero? I want to check to see whether one of them is zero. I want to be sure that exactly one of them is zero. What's going to happen if I say not frozen? Again, you can always push pause and think about this. You may go back to the lecture or your book to review. What is the advantage of using the type Boolean rather than strings? So we could basically ask the user to type in false or true, or we can ask the user to put 0 or 1. That's the old-fashioned way when we were writing C programming before C++, and we did not have Boolean at that time. So we were using 0 and 1, but that's no excuse to use it right now. So we got to practice on the Boolean variable. So that's end this section for us.